When people first test an AI agent, they usually focus on the most impressive moment. Can it answer a question, call a tool, draft a report, or complete a task chain without obvious help? But in real products, the most fragile point is usually not the first action. It is the handoff. One step gathers context, another plans, another calls tools, another waits for approval, and another has to package the result for a person or another system. Every transfer creates risk. Important state gets dropped. The goal becomes fuzzy. A tool returns data in one format while the next step expects another. A human reviewer sees something different from what the agent thought it sent. This is why agent demos can feel far more reliable than agent products. A demo often lives inside one control path. A product lives at the boundaries. If your workflow cannot survive handoffs, it does not matter how smart any single step looks in isolation. In software language, a handoff sounds like a routing issue. In product reality, it is a state transfer problem. The next step does not just need a message. It needs the right subset of task history, constraints, assumptions, permissions, and an expected output shape. If that bundle is incomplete, the next steps start supervising. And once an agent starts supervising at a boundary, small errors become system errors. This is why experienced teams talk less about raw model power and more about context engineering. Bigger models can sometimes patch over weak design, but they do not remove the need for explicit state. In fact, larger systems often create the illusion that state is being preserved when it is really being guessed. A good handoff says exactly what the next stage must know, what it should ignore, what format it should return, and what counts as success. Without that, you are not orchestrating a workflow. You are asking a model to recover structure that the product failed to specify. One common reaction to handoff failures is to pass more information. Entire chat logs, giant memory dumps, long retrieval results, extra policy text, tool traces, and all prior reasoning get thrown into the next prompt. Sometimes that helps for one run. Often it makes the system noisier. The next step now has to decide what matters, what is stale, and what was only relevant to an earlier branch. This is where many agent systems become expensive and confused at the same time. Strong handoffs are selective. They compress state into a task-ready form. What is the objective? What evidence is approved? What tool outputs are canonical? What uncertainty remains? What must happen next? Context is not a pile. It is an interface. If you do not design that interface, the model spends part of every step solving the wrong problem, which is reconstructing the workflow itself. That is costly. And more importantly, it is unreliable. Another hidden failure point is the contract between the agent and the tool layer. In many systems, a model calls tools whose inputs are loosely described and whose outputs are only semi-structured. That may look flexible, but it makes handoffs brittle. If one tool returns a paragraph, another returns JSON, and a third fails silently or uses inconsistent field names, the agent chain becomes hard to trust. Product teams sometimes treat this as a model problem when it is actually an interface problem. Reliable handoffs need strong schemas, tight outputs where possible, explicit success and failure states, and a clear rule for what the next stage should do when data is incomplete. This is one reason modern agent frameworks keep moving towards structured outputs. validation, and observable tool traces. The goal is not elegance for its own sake. The goal is to stop meaning from leaking between steps. There is another mistake in agent design. Teams assume every handoff should become fully automatic, but some boundaries exist for a reason. Compliance review, customer communication, legal escalation, payments, and high-cost operations often need a human checkpoint. The question is not whether people slow the workflow down. The question is whether the system knows how to hand work to a person without losing context or creating rework when it comes back. Bad designs dump a huge transcript onto a reviewer, then ask the model to continue from whatever it can infer afterward. Better designs summarize the decision state, show the unresolved issue, record the human choice in structured form, and restart the workflow with explicit updated state. That is still a handoff problem, just a human one. And it matters because a real production workflow usually combines model steps, tools, rules, and people. If your architecture only looks good when humans disappear, it probably is not ready for the environments where reliability matters most. The teams that build more reliable agent products usually converge on a similar playbook. They reduce unnecessary agent count. They make handoffs explicit. They define state objects instead of passing vague prompt residue. They validate tool outputs before the next step consumes them. They log transitions so failures can be replayed. And they decide in advance which boundaries belong to automation and which belong to people. Notice what is missing from that list. It is not bigger context windows. It is not blind trust in autonomy. It is not the hope that a stronger model will somehow absorb a weak product design. The practical lesson is that agent reliability is a workflow design problem before it is a model race problem. Handoffs are where the workflow tells the truth about itself. If you want agents to work in the real world, design the boundaries first. The intelligence inside each step still matters, but the system lives or dies on how well work moves between them.